Welcome to Work Execution Process Descriptions, and thank you for your interest. We hope you'll take the time after this short presentation to explore the other Triad Unlimited presentations on YouTube, follow us on LinkedIn, and visit our website to see all our services and training offerings. After work is identified, planned, and scheduled, we need to ensure that we execute the work safely, accurately, and on time. The work execution function processes are designed to promote that type of work execution. As was the case with the previous three functions we've already covered, there are four processes that comprise work execution. First, we'll cover considerations when developing and implementing standards for routine work execution, then emergent work, outage work, and finally, contracted work. When we execute routine work, we want to document the work consistently and accurately. The documentation allows us to analyze various data points from the work order over time and improve reliability. Executing emergent work based on criteria ensures we don't artificially inflate the urgency of any given issue and wreck our work schedule. Reviewing outage performance allows us to collect lessons learned and continuously improve outage management. Managing contracted work to our standards protects the business from variations in quality and compliance. The work order is like, and in some cases is, a legal document. If it isn't written down on the work order, it didn't officially happen. Whether a hard copy, or as is becoming more common, an electronic form, the work order is the currency of the work management system. When developing or improving work execution standards, it's important to craft the work order with end users in mind. These include not only the technicians executing the work, but reviewers, auditors, data analysis personnel, storeroom specialists, managers, and so on. Almost everything we can know about an asset's reliability depends on accurate and complete work execution and documentation in the work order. So, it's important to be able to tell what happened during work execution. Was the work requester's issue resolved? Was the job planned correctly? Are there ways to improve the work next time? What caused the problem? How long did the job take? Who did it? When implementing this function, care must be taken to ensure the full story can be told and standards developed to ensure collection of the necessary information. Mobile solutions are a great help in all this, since input of certain information fields can be made a requirement in order to close out the execution phase of the work. The greater precision in work execution and documentation, the better the overall work control system performs toward its goal of preserving asset functionality. Making sure the personnel performing the work are properly trained and qualified goes a long way toward each job being done correctly. Being able to assign work to qualified technicians enables the maintenance organization to be more effective in getting the job done right the first time and promotes organic training opportunities. Remember, if we don't train our technicians on the tasks that we develop to prevent or mitigate the known failure modes for an asset, then everything we've done to this point is meaningless. Accurate and precise task execution is our protection from early asset failure. It prolongs the time an asset operates as we desire before we encounter a potential failure. Previously, we've talked about emergent work as in the case of an emergency where there's imminent danger to equipment or personnel or the environment. There's another type of emergent work as well. When doing an inspection, what happens if failure indications are discovered? In theory, the inspection is performed close enough to the P point on the P to F curve to allow time to perform a separate corrective work order to address the found issue. In practice, we always say, well, we're already here, the equipment's already locked out, and we have qualified people at the job, why not just go ahead and make the repair? Without some specific criteria, this is not a good idea. You might need to go search out parts, perform some extra support work like insulation removal or something like that, and guess how much longer the repair would take relative to the schedule requirements, and then evaluate any work that won't get done as a result of dedicating resources to unanticipated repairs. The bottom line is that some proactive tasks anticipate finding a failure mode in progress, and they identify allowable repairs that can be made on the spot. These are generally the condition-based tasks that we're trying to design the maintenance program around, and we develop those tasks in terms of quantitative data or observations that serve as a go or no-go indicator for continued operation of a part. So every task we develop must recognize what is to be done when a failure indication is found. It is best if the work instructions state in clear terms to do a repair or to write a corrective work order for later execution. This decision is risk-based and linked to the consequences of allowing failure to continue within the P to F curve while work is planned and scheduled. Outage work execution is pretty much the same as routine work execution, except there are usually more resources concentrated in the work area. Care must be taken to ensure workers don't try to occupy the same space and time and interfere with each other's efficiency. There's also often a sense of urgency or schedule pressure that requires management to ensure work isn't done in a hurry, thereby increasing the likelihood of infant mortality and failure during startup. Outages aren't over until they've been reviewed for lessons learned. When working on this function, consideration must be given to the idea of what to do when the outage is over. If the organization is new to outage management, it's a good practice to develop a formal outage closeout checklist to ensure all necessary data is collected. Generally, the post-outage review considers two elements. The first is whether quality work was accomplished on schedule, and the other is about whether the forecasted budget for the outage was accurate. This should be a formal review that involves all outage stakeholders, and action items should be tracked to completion in a reasonable time prior to the next shutdown. Incorporation of lessons learned, remedies should be evaluated for effectiveness where possible in subsequent outages. Outcomes should be published, as should wins from improvements. Regardless of how contractors are engaged within the organization, safe and quality performance is everything. Partnership with contracted services must be regularly reviewed for benefit to the company and compliance with its standards and culture. Contractors should be required to supply a specific set of data for evaluation at least annually. Management and supervision of contractors should be reviewed, including any issues requiring resolution since the last reporting period. In summary, key points to remember when you're implementing or improving work execution functions is to require work documentation, to manage emergent work resulting from proactive tasks, to review outage performance, and to consistently manage contracted work. This concludes the work execution process descriptions presentation. Thank you for participating.